Picture it, the steady, rhythmic beep of an operating room monitor. It's a sound we've all heard, right? Tens of millions of people undergo general anesthesia every single year. It is practically routine. Yet, it remains one of the most deeply mysterious procedures in modern medicine. In this explainer, we're diving into a monumental discovery recently published in the journal Nature. It's a study that fundamentally rewrites our understanding of the human mind. So let's step into the shadows and uncover exactly what's happening in the dark spaces of an anesthetized brain. When you lie on that operating table, the anesthesiologist usually tells you the same soothing words every single time. You'll go to sleep, you'll feel nothing, you'll be completely unaware. And then, ideally, you blink, you wake up, and the whole thing is over. For decades, the medical consensus aligned perfectly with this comforting promise. We essentially believed that general anesthesia was like flipping a switch, just completely silencing the mind until it was safe to wake up. But the unsettling scientific reality we're about to unpack, it shows us that this clinical promise is only a fraction of the truth. Recently, researchers at Baylor College of Medicine deployed some of the most advanced neural recording technology ever built, placing it directly into the brains of anesthetized patients. And the finding that emerged from this data, it changes how every single person on Earth should think about going under. Because the brain does not go silent. It keeps working. It keeps learning. It is actively listening to every word being spoken in the room. And remarkably, as we'll see, it even tries to predict what comes next. Now, to really grasp why this is such an absolute game changer, we have to look at what we thought anesthesia was doing. General anesthesia floods the brain with some incredibly powerful drugs. Historically, science told us that these drugs silenced the cortex. That's the outer layer of your brain, the part responsible for conscious thought, perception, and awareness. The belief was pretty absolute. No cortical activity means no consciousness, no experience, literally nothing happening inside. If scientists ever detected faint sensory echoes in the past, they basically just dismissed them as residual noise. But a team led by neurosurgeon Dr. Samir Sheth at Baylor College of Medicine, well, they wanted to look past that outer layer. They set their sights on the hippocampus. It's this tiny, seahorse-shaped structure buried deep, deep within the brain, far away from where raw sensory information first hits. It's famous for being the control center for memory and learning. The researchers knew something crucial. If the hippocampus was still firing during anesthesia, it wouldn't just be leftover noise. It would mean the brain was genuinely processing information, still working, still in some silent, mysterious way, thinking. So, how do you actually look inside a living, entirely unconscious human mind? The researchers found an extraordinarily rare window of opportunity. They identified patients undergoing epilepsy surgery who already needed electrode probes implanted deep inside their brains. While these patients were fully under general anesthesia, the team used cutting-edge neuropixels probes. This technology allowed them to record from hundreds of individual neurons simultaneously, right there in real time. They were capturing something that had quite literally never been measured before, in this precise region, under this deep level of unconsciousness. Okay, so their first experiment was deceptively simple, but the results completely stopped the team in their tracks. They played a series of repetitive audio tones to these fully unconscious patients, and occasionally they interrupted those tones with a different, completely unexpected sound. Incredibly, the neurons in the deep, dark void of the hippocampus actually distinguished the difference between the boring, repeated tones and the unusual ones. But even more staggeringly, the brain's performance actually improved over time. The unconscious brain was exhibiting neuroplasticity. It was rewiring and strengthening its responses based on experience, all while the patient was entirely unaware. As awe-inspiring as that is, the researchers decided to push the envelope. If the brain could learn from simple beeps and tones in the dark, what else was it actually capable of? So they stopped the tones and started softly playing clips from educational videos and storytelling podcasts right there in the operating room. They introduced full, complex spoken language, complete with proper sentences and real human speech, to patients who were totally paralyzed and heavily anesthetized. And the hippocampus? It responded. The data didn't just show that the brain heard a noise, it revealed real-time language processing. The unconscious brain was actively sorting the incoming words by their grammatical category. The neural firing patterns were distinctly different when the patient heard a noun, compared to a verb, compared to an adjective. Think about that for a second. The pitch-black void of the anesthetized mind was actively organizing human grammar. But the researchers found one more detail, And honestly, this is a detail that might give you a bit of a chill, permanently altering how you view the line between awake and asleep. The brain wasn't just categorizing words as they happened. No, the brain reads ahead. It was actively attempting to predict the next word in the sentence before it was even spoken out loud in the room. In the neuroworld, we call this predictive coding. It's a mechanism that constantly calculates the most probable next word based on everything that came before it. Dr. Benjamin Hayden, one of the study's co-authors, really hit the nail on the head when he pointed out the intense paradox here. Predictive coding is something we strictly associate with being awake, highly attentive, and conscious. Yet, here they were observing it happening in real time within patients who were completely unresponsive on an operating table. There is an eerie and fascinating parallel here. On one side, we have the unconscious human brain running this predictive coding. On the other side, we have modern artificial intelligence language models. This exact mechanism, calculating the most probable next word based on context, is literally how an AI like ChatGPT generates text. Your anesthetized brain is quietly running a profoundly complex analytical process, eerily similar to a highly advanced AI, all while completely submerged in general anesthesia. Put yourself on that operating table for a moment and think about what this means. The reality is stark. You are unable to move, you are unable to feel, and you are definitely unable to remember. When you wake up, you will have absolutely no recollection of the stories or the sounds played around you. But you are listening. Your mind is analyzing. It is predicting. The entire time you believed you were just turned off, your brain was actively working in the darkness. Now, before we get carried away, we must be absolutely clear about the medical reality here. As Dr. Samir Sheth notes, our findings show that the brain is far more active and capable during unconsciousness than previously thought. It is absolutely crucial to reassure you that there is zero evidence here of pain, distress, or memory formation. You aren't suffering. However, it definitively proves that the old, simple theory, the idea that the brain is simply powered down, is fundamentally busted. The ripple effects of this single publication are massive, stretching across multiple fields of science. For brain-computer interfaces, understanding how the unconscious mind processes language opens up revolutionary ways to decode neural activity, which could eventually help non-responsive patients communicate. For anesthesiology, well, it forces a total reevaluation of what depth of unconsciousness actually means during the millions of surgeries performed every year. And for the philosophy of mind, we finally have hard, empirical evidence challenging our most basic definitions of awareness. Ultimately, what this explainer reveals is that the wall we built decades ago between conscious and unconscious, awake and asleep, present and absent, just got a whole lot less solid. Anesthesia isn't just a simple off switch. It occupies this strange, active, mysterious middle territory. And this opens the door to monumental future research. Does this same processing happen during deep sleep? What about in a coma? The brain is doing so much more behind the scenes than we ever realized. Somewhere in a hospital right now, a patient is counting backward from 10, and somewhere around 5, their conscious mind is going to go completely dark. But in that darkness, deep inside, a single neuron in the hippocampus is firing, listening, sorting, guessing what word comes next in a conversation it will never remember hearing. So we're left with a haunting question. Where exactly is the line between someone being there and someone simply being silent? Thank you for exploring this mystery with me. Keep asking questions and keep looking deeper.